SaaS is dead. Agents are what's coming next. You better know what they are. So what are AI agents? Here's a quick definition, and we'll get into more detail in a bit. But an AI agent is capable of autonomously performing tasks by planning its own steps and using available tools. We'll explain each step of that as we go through. So first off, it perceives its environment. It knows what's going on. It has context. And it does this not just at the beginning, it does this multiple times throughout the execution of the task. It then makes decisions, so it reasons, and I put the word reasons there because you'll hear about reasoners and reasoning and why that's a big deal. It then takes actions towards a goal, so that's using tools. It's not just generatively chatting with you, it's also calling in tools and APIs and actually impacting the world in some way. But it does all of this without needing step-by-step instructions for every scenario. That's the key difference, because there are many AI systems that do have step-by-step instructions all the way through, and they work too, and we'll see why. So breaking that down, first off, perception. So it needs to understand what's around it. It needs to know where it's up to, what it's doing, where it's at, what blockers it has, all that kind of stuff. So an easy way to think about that is a physical robot knowing that there's a desk in front of it, so it can't walk straight forwards, right? A Tesla, for instance, has a good world model from its cameras. Other ones have radar, all that kind of stuff. For AI digital agents, which is what most of us are probably building, it's going to use data streams. So it's going to pull that in from APIs and user inputs. The prompt, for instance, like giving it a goal, that's a thing it needs to perceive. And it has memory of where it's up to at the moment and previous interactions and previous attempts at that task. Now, we'll get into reinforcement learning and continuous learning a little bit later on, but these are methods where it can understand the context of the past as well as the present. So, step 2 is decisions. So now this is planning. So if you give, for instance, if you give me the goal of go to the airport, I'm going to need to break that down into subtasks. And it's called hierarchical planning because, for instance, my first task will be to get to the front door, right? But even that, I need to break down into tasks. I need to turn left. I need to move my right leg forward, etc. But if I do that and I start doing that and then the cat runs in front of my feet, I'm broken, right? If I had this whole thing planned out in advance, waterfall style, I can't really, that's not going to fare well once it actually hits the real world. So I need to make decisions. I need to predict what I think I'm going to need to do. And then I need to reassess iteratively and dynamically each step of the way as I reach something that I wasn't predicting. So to do this, for instance, for me to get to the airport, there's theoretically an infinite number of ways that I could get to the airport. I could start by turning this way, I could start by turning that way, I could go via Penshurst, whatever, right? But I need to work out the most efficient way for me to get to the airport and what those sub-steps should be. And then I need to be adaptable when the cat tries to trip me up. So the third part we said was tools, right? This is taking actions as opposed to just generating responses. These are generally integrations, which in tech talk is APIs, that let them act in the world. So agents, agency, taking actions. So for example, it might be pulling in the information it needs. Remember, it needs perception. Sometimes perception requires tools. So cameras, browsing the web for more information. There's something called RAG, which is retrieval augmented generation, where it pulls in extra information and extra context into each prompt. It could be running code via an API, so that means just interacting with any other piece of software. Updating a database. This is important because for our SaaS systems, we have things like CRM systems. Maybe you have an interaction with a client and you want to update the client record to say that you had that interaction. Or there's a financial transaction and you need to make sure that, the money in that database has moved to that other database. It could be physically clicking buttons in a user interface, so actually using physical screens. Or it actually could be literally physical interactions, closing the blinds, turning on the thermostat, whatever. And interestingly, It can be invoking another agent. So I'm one agent and I want another agent to help me out with a step that I can't do myself. It could also just be using a classical AI system as well. So memory is interesting. You have short-term memory within a session. So, I start going to the airport and I remember that, at the beginning I grabbed my passport and I have that at the end, for instance. And then the more interesting one is long-term learning. So this is an agent which, for instance, a self-driving car knows that it almost had an accident when it tried to turn right when there was a car too close to it. So it shares that information with the rest of the fleet. Now the whole, learning system knows that that is not something you want to do. Let me break down the difference between reinforcement learning and continuous learning. Continuous learning is iterative. Every time you do something, you learn something. You do something, you learn something. Reinforcement learning is a training run that is done with something called a reward function, which basically says, yes, good job, you did a good thing, or no, that wasn't good. This works best in spaces where that's obvious. So this is why coding agents are becoming so powerful so quickly, because there's an obvious reward function when code compiles and works or it bugs out, right? So those spaces where there are obvious reward functions are more ripe for more intelligent reinforcement learning. If anyone's heard of DeepSeek, it's got as far as it did by pure reinforcement learning with no human input at all. If you've heard of the aha moment, that was what that was, when they went, oh my God, how can we get this far with no human input at all? All right, so these systems are autonomous, right? You're not helping them every single step of the way. They can go some distance, however comfortable you are to let them go nuts, without necessarily a human interacting. So optionally, at different points, you can have a human in the loop. Human in the loop is a term you'll hear a lot, and you'll probably hear it a lot more. This is how much human oversight or interaction needs to be done. You could theoretically have an agent where a human literally says, yes, you can move your left foot. Yes, you can move your right foot. Yes, you can turn the doorknob, right? You can have it approve every single step of the way. An example of that would be something like Cursor or GitHub Copilot, where at the moment it gives you suggestions for pieces of code and you go, yeah, I'll take that. Yep, that works. Yep, beautiful. So instead of typing everything yourself, it's kind of just jumping you ahead a little bit of autocomplete. But realistically, to be fully agentic, you need to be more autonomous than that. You need to be able to go a number of steps before requiring a human to go, okay, yep, you're still on the right track. And as I said, a human in the loop is theoretically optional. So this is an interesting way to think about it. You're giving it the what and the why. You're saying, I want you to go to the airport so you can go to England, but not the how, right? So you're not saying, left foot here, right foot there, turn left at the signpost, whatever. Okay, so figuring out the how is up to the agent, and that's the main difference between an agent, an agentic system, and a non-agent. There are some limitations for this. It can't do everything. First off, it's less predictable, it's more creative, and less predictable than a predefined workflow where you say, left foot, right foot, turn the doorknob, turn left. You know exactly what's going to happen every time with that system. With this system, you don't know what's going to happen. There's a famous example of, there's a guy in South Korea called Lee Sedol, who was the world champion Go player, and he was beaten by a system called AlphaGo, which was trained using only reinforcement learning. And it did a move called Move 37, which is where, I don't know if you guys have played Go, but you put a little stone on a board at different coordinates, and it put this stone in this coordinate that no one was expecting. It made no sense at all. And they went, oh, it's lost, it's bugged out, it's done something really stupid. It turns out that was genius, and no human had ever thought of it. So it can work out, the unpredictability can work out, the creativity, but sometimes, you really were expecting it to do something simple, and it went off and did something huge. It could have not a full understanding of the situation. An agent feels a lot like a human assistant, and sometimes we can be fooled into thinking it is a human assistant, and so we give it a task the same way I might give my assistant a task, and I assume we have a certain amount of shared human upbringing and understanding of the world. We've got a similar world model, similar values, all that kind of stuff. So if I say, take the dog out, I don't assume that he's going to shoot the dog, right? Like, I assume that means he needs to do a wee, right? So it's a pretty extreme example, but it's a good idea to be empathetic with the fact that it doesn't have the same context as you yet, right? As I said, continuous learning, they'll gain context over time, But at the beginning, when you're using agents, sometimes it'll do things that you think, you idiot, what are you doing? Surely you understand that basic thing that we all know. But yeah, having that empathy to realize it's like a newborn that's been put into a scenario, right? So you need to inject more context sometimes and give it more explicit explanations of some things that we take for granted. It may have a need for oversight, so having a human in the loop. It doesn't have to be a human that's in the loop, by the way. It could be another AI system. But at the moment, because it can go off and do whatever it wants, you don't know exactly what it's going to do to achieve the goal. You don't know what those sub-goals are going to be. At the moment, there is a need for oversight. And it can be expensive. It can spend more time or more compute and more money and more energy and more water, et cetera, doing what you think is maybe a simple task because you've done it 1,000 times. You just click here and go. But it goes off and searches everything and comes back and researches, and like you don't know how far it's going to go down the rabbit hole. So compared to a predefined workflow where you've already optimized exactly what you wanted to do, sometimes agents can go a bit roundabout. I should say, this is limitations of agents now. Though I think all of these will reduce over time. So to compare that against AI workflows, right? An AI-enabled workflow, this is what a workflow looks like. You've all probably bought a book from Amazon before. It's a pretty simple kind of flow chart. You come in, you register, or you're already signed in, or whatever. You choose the book, which kind of one do you want, how do you want it done, where do you want it sent to? Like simple stuff. Basically, every customer goes from A to Z via one of these paths, right? This is a simple way to explain most software, and especially AI-enabled workflow systems, work somehow like this. So it's an AI-enabled decision tree. Every time there's a branch, well, not every time, but a lot of the time when there's a branch, you'll have AI figuring out, is this scenario or that scenario? It's also known as a compound AI system or a large action model. So large action model is a relatively new term. It's being used a lot now in the startup scene. I don't like it, really, because it sounds like it's a comparison against a large language model, and actually they're very different things. An LLM is the intelligence at each step of the way, and a large action model is the whole thing. So I think it's not really a helpful thing, but anyway, you might hear it, so now you know what it is. And it's a predefined sequence of steps. Every step has to be selected and worked out ahead of time by developers. And so this works well for a really well-defined problem that's like a narrow, understandable, we need to get from A to Z kind of task. So this is used a lot in robotic process automation, which is known as RPA, if you hear that term. And for the last couple of years, this has been blowing up massively. I'll show you why in a sec. And it can still use tools, right? So a lot of people think that this is an agent because it can act. Right? It can use tools. It can call other things. It can act. This is not an agent. So to illustrate this, let's go back in time. Let's go a long way back in time, all the way back before November 22, before generative AI was a thing, to rules-based AI. Sorry. This was cool. This got us a long way, right? But we don't do this anymore, mostly. So let me explain what this looks like. Here's an example of a customer service bot. You've got a situation, the customer sends a message, right? If any of you have ever used Outlook rules to figure out, is this spam, is this not, is this from the boss, so I'll just delete it straight away. He's not paying attention. It looks at keywords and phrases and simple metadata. It looks like, am I in the CC or the to? Very, very black and white if-then kind of statements to work out if it matches a pattern, and if it does, if it matches one of those rules, brilliant, okay. They said, I want a refund. The word refund was in it, so we'll just send them the link to our refund standard, right? This was used for something called ticket deflection. So a customer service ticket is every time somebody queries a customer service person and says, hey, I want a thing. And they found that 80% of these were the same questions over and over again, so they worked out simple ways to just deflect very repetitive, very routine kind of questions to just, here's the knowledge base article, here's the link, here's the pre-canned response for this answer. And then if it doesn't match one of those rules, it escalates back to a human, so it doesn't deflect the ticket, it goes to the human. They send the response, it doesn't learn over time, it just does the same thing every time. This worked fine. We have a system called Zendesk that used this for quite a long time. It was fine. So it's got fixed rules and fixed responses. It's looking at keywords. It doesn't actually understand the problem. It doesn't understand what the person's saying. It's just saying, oh, he said unsubscribe. Send him the unsubscribe link. It can't handle even different phrasing of the same question, like, I want my money back instead of, can I have a refund? Don't know what you mean. I'll send you a human. It's always going to escalate anything it hasn't seen before. It never gets any better. And the responses are just the ones that have already been written in a list of here's all the responses, the library of responses we can use. So this is rubbish, right? This is probably still used in some very, very narrow cases, but very rarely. Now we have AI-enabled workflows. So the same exact example, right? We have a customer who sends a message. The AI looks at the message, it understands it, and then it checks against a knowledge base of every question that's been asked before and every answer that's approved, and also just the actual reasons behind the answer so it can nuance and think about it itself. It works out, is this a simple enough question that I have the information I need to generate a response? If so, it then generates a nuanced response, so specific to the context of the question. The person, all the information it has about the person, all the information it has in its knowledge base, it puts it all together the same way if any of you have used ChatGPT before, it gives you a specific answer to your case each time. If it works out, you know what, this is above my pay grade, it'll still escalate to a human, so you can avoid excessive hallucination. And then at the end, it might go, right, we had to escalate to a human because it was a case we hadn't seen before, but the customer was really happy and gave us a thumbs up at the end. Let's take the response from the human, put it back into the knowledge base. Now, next time someone comes through, we have an answer to that question. So this is really good. We've been building these for a couple of years, and I think we'll still keep building these for quite a while. You don't always want to use an agent. Sometimes this is good. So it does understand the meaning. It's not just looking at the keywords. It generates a specific response based on what they want. It can handle new kinds of questions, new phrasing, any different way of coming at the problem. So long as it's a problem it has some knowledge on, it can still handle it. It learns over time. And most importantly, the person feels like they got an actual response from somebody who cares about what they're talking about and is specific to them. So that's really good. I don't think there's going to be a place for those forever, and I'll tell you why, but I think for now, those are still very good. But here's the new paradigm. Here's the agents. So customer sends a message. The agent analyzes it. It looks at its available tools. So we talked about the tools before. What can it do? It's aware of what it's able to do and what it's not. And then it plans out its steps, its sub-goals, to achieve the outcome. So that's why we have question marks at the bottom there, because before the query comes in, we have no idea what it's going to do. We don't know what the workflow is going to be. It's going to be generated every time for every new query. So it figures out what to do with the user's query. For instance, I had to think of an example where it was something that was a bit off the wall that a human probably hadn't thought, oh, a user's probably going to ask this, so forgive this. Where's my order? And is it too late to change it? Agent asks for more information, takes the customer ID, checks the database, checks the status of the order, gives a more nuanced response, and then anticipates any follow-up questions and asks for information and gives things ahead of time. User goes, you know what, just cancel it. Well, hang on, before we cancel, we can offer you a discount, et cetera, et cetera. Now, obviously, now that I've mentioned that specific flow, all of you are thinking, oh, well, I could make a workflow that would handle that. But the point is you didn't have to, right? And so you don't have to think ahead of time every single possible way someone might want to interact with the system. You just build the system, give it the intelligence, give it the tools, put some boundaries around it, and let it out into the world, right? This is very, very powerful, especially in more complex or open-ended kind of scenarios. So this is the fun part of the talk. Real-world AI agents that you can use right now. So first off, I wanted to start with self-driving cars, and this is because it's the easiest to understand. Everyone's driven a car. You know the sort of judgment calls you need to make about, shall I use the brakes, shall I overtake, shall I indicate, shall I not? Like, we learn the fundamentals of using the car at the beginning, but then there's so many nuanced different situations that you have to deal with. And I found a video of the current state of full self-driving. All right, beautiful. So if you look on the right-hand side here, you can see, the different kinds of scenarios that it might have to deal with that might be a bit tricky, like changing lanes. An unprotected turn, by the way, I found out is when there's no green arrow or give way or anything like that. It's like you've just got to figure out when to turn. Detours, so the lane isn't where you need to drive. You need to follow the cones or something instead. Obviously not running over small babies. Curvy roads, if anyone's driven a Tesla, this is always the part that freaks me out because it turns a little bit too much and you think, is it just going to drive off the side of the road? Mergers, 2 lanes become 1, or forks, where 1 lane becomes 2. They're going the wrong way because it's in America, but it's a roundabout. Stop signs, etc. So that is pretty cool. It's actually amazing to see how good that is, and I'll get to that stat that's there at the end in a second. So it's kind of the quintessential open-ended complex problem to solve, right? And we've been trying to solve this for ages before we had generative AI, before we had reasoners. And the way we tried to do it, originally in 2004 to 2007, DARPA gave a grand challenge where they were offering a massive prize to anyone who could solve this problem, and they were all trying to solve it with AI workflows. And they weren't even generative AI workflows. They were just, if-then statements. If a car comes like this, go like that kind of stuff. And the massively complex human-generated workflows of trying to solve this problem. That's started to become, it was starting to show it's just we're never going to get there. Outside of very controlled environments, it just wasn't going to work. So we had a very slow shift towards neural networks and machine learning instead, which then moved towards agents. So from 2015 to 2017, it's been fully pretty much agentic. Tesla and Waymo from Google are the leaders in this space, and NVIDIA as well. And they're using deep learning and reinforcement learning, which we talked about before, and they're getting some really good results. And this really established the agent paradigm. And it's a good one because everyone can understand this, right? It's not a quintessential, like a weird, cloud thing or something. It's very physical. You know what it's talking about. The stat that I found out, and I'll tell you how I found it in a second, is that Tesla full self-driving is already 5 times safer than human drivers. So the stat is that it only has 0.3 accidents per million kilometers versus 1.5 million, which is the average for humans. So that's a pretty interesting stat. And you would think in a completely rational world, human drivers would now be illegal, right? And we'd all be in full self-driving cars. The problem is probably everyone in this room assumes that they are the one person who is better than the full self-driving car. So regulation's probably not going to come in to allow this until it's 100 times safer than humans, 1,000 times safer. Because at least if you crash your car, you go, whoops, that was my fault, my bad. But if a self-driving car crashes into a wall, you're going to be pretty pissed about it. So it uses perception, it uses its cameras, LiDAR, radar, GPS, etc., and it builds an accurate world model. Keep an eye out for that term, world models, by the way, because you're going to hear a lot of that. Not in this talk, but in general, in the next couple of years. There's a lot of work going into accurate world model building for training robots and cars. So we said, it has perception, it makes decisions all the time. Should I turn, should I not? Is this an unprotected turn? Is that car coming too fast? Is he indicating? Whatever. And it's got to work out. It's been given a goal, get me to work, and it's got to get there while making sure you're safe, making sure traffic rules are not dodged and sufficient, all that kind of stuff. And then obviously the tools in this case is the accelerator, the brakes, the steering wheel, the indicator, all that stuff. And then this is the fleet-wide data sharing that I was talking about. This is where every car's interaction with the world teaches not just that car to become a better driver, but all cars to become better drivers. And that theoretically is Tesla's biggest moat, is that they have the most recordings of driving because they've had people, doing supervised driving where the car is still recording and still taking its learnings and sending it back home. So the idea is to scale down the supervision, scale down human input until we do reach full self-driving. Has anyone driven in a Tesla before? Or Waymo or anything? Just about half the room? Okay, cool. All right, now this one's fun. This one enabled me to put this talk together. This is OpenAI's deep research. This only came out 3 weeks ago, right, on February 2nd. Actually, less than 3 weeks ago, 2.5 weeks ago. And this is an absolute game changer, and I recommend everyone give this a go, and you'll be able to soon. What you do is you give it a complex research prompt, and it searches the web, reads and analyzes hundreds of sources, including web pages, PDFs, images, and then compiles a comprehensive report with citations. So as an example, this is my prompt when I was trying to start this talk, right? So I put this in, I went into voice mode and I just context dumped into it and said, here's what I want. I hit deep research and I started. First thing it did is it asked me a bunch of clarifying questions. That was important because you don't want it going off answering the wrong question. It's going to take a little while. I answered all those questions. And then it just said, right, I'll get back to you. It spent 4 minutes. It looked at 24 different web sources and it came up with this. This is really the bones of the talk that I'm giving to you right now. This was gold. This was so helpful. So this was 15 pages and 4,500 words, and more importantly, really, really useful links that I could then go into and do further research as well. So how does that work? You give it a prompt. You can also give it files, by the way, for extra context if you want. It then works out. The reason this is agentic, it's not just doing like a RAG thing, a web search, and then give you the answer. It's working out, right, what's this person trying to actually achieve here? What am I going to need to learn? How am I going to put that together? And what steps do I need to take to do this research? And then as it goes through and it starts to find useful things, it goes, that's great. And now I'll look, more in that space, or I'm looking here, that's not really bearing any fruit, so I'll stop looking and that kind of stuff. So again, it's got that dynamic re-prompting, or replanning, sorry. It gathers the data, so it's searching the web, it's looking at all the articles and papers. It puts more weight behind anything that it feels is peer-reviewed or useful, and it gives less weight to, people's Twitter feed or whatever. And then it analyzes it, puts it all together into a structured report with citations. So it also tells you how it found it, what it found, the links so you can go and check for yourself if anything's wrong. Now, it's not completely immune to hallucinations. It's substantially less prone to hallucination than a normal prompt because it's doing so much kind of rechecking. But be aware, it's not completely immune yet. So it uses O3. It's the only way to use O3. So OpenAI has a bunch of different models. The O models are its reasoning models. And O3 Mini is available for use at the moment, but O3 is not. This is literally the only access that anyone outside of OpenAI has to their strongest reasoning model. It can take up to half an hour and lots of compute. So because of that, before you start, do a bit of your own research. Don't just go, I'll start with this. Start with a little bit of your own research. Start with a voice chat with ChatGPT, just talking around the problem and kind of getting a feel for it and bouncing some ideas around. You want to frame your question correctly because it's going to take a while. It's going to take a lot of resources, energy, water, compute, all that sort of stuff. The things you don't want just going off and being irresponsible. In my case, the time is the most important thing to me. And then afterwards, as I said before, the citations are really useful. So in this case, I had seen a little bit of IBM stuff in the past, but it hadn't been super relevant to me at the time, and I kind of dismissed it. And I was like in my normal everyday AI research was looking in other sources. But it used a lot of stuff from IBM, and I wondered why. So I started looking at IBM's YouTube videos, and they were fantastic. They were really, really good. Now that I had enough base knowledge to understand them more, they're a bit more advanced, but I really enjoyed them, and a lot of my knowledge from this has come from the IBM researchers. So I wouldn't have found that without the deep research doing that legwork for me to find that. It's really useful. Now, the competitors. So Google came up with this concept first, right? Google Deep Research came out in December, right in the middle of OpenAI's 12 days of shipments, just to mess them up. And it was, at the time, it was amazing, right? Perplexity came up with one on February 14th. What was that? That's 5 days ago. And Grok came out with one yesterday, right? This is how fast this space is moving. But of all of these, the OpenAI Deep Research is the strongest. There's a test called Humanity's Last Exam, and it scored 25 in that. That's supposed to be kind of the AGI test. If you can beat Humanity's Last Exam, they call it Humanity's Last Exam terrifyingly to say, if it can beat this, there's nothing else left to beat. It's just let the AI do everything after that point. Just for example, Perplexity got 20%. All right, next one. Well, actually, first off, who thinks that last one was cool? It's so good. Actually, let me just quickly tell you, I had to use the $200 a month subscription, the pro subscription to ChatGPT to access that at the moment. It's coming to standard $20 a month plus accounts in the next month or so. So you don't need to fork out the $200 a month. Just for now, just use the Perplexity one, use the Grok one, and wait a month. But as soon as it's available, please use it. It's amazing. All right, OpenAI's Operator. So who's heard of this one already? Who knows what this is? A few people. So this is a bit of a game changer. It's OpenAI wasn't the first one to come up with the concept. I'll talk about the competitors in a bit, but at the end of January, so again, like 3 weeks ago, OpenAI came out with theirs, and it's much better than the competition. And I'll show you using it here. So hands off, I'm not doing anything. I said at 11 o'clock at night, I said, get me a large pepperoni pizza delivered to my address on Wednesday at 8 p.m. And I like to dance, so instead of doing this, I'm just going to dance a little bit. This is much better. Excellent. Okay, good. So what's it doing here? All right, brilliant. It is, well, it thinks I'm in America because I had to use a VPN here to get access to this because you can only use it in America. So it looks up pizza in America. That's so good. All right, it knows I'm in Australia because I've given it custom instructions to tell it my address. So it goes to Cross Pizza in Australia, goes to delivery. Oh, it's one of those ones where you have to type it in and it's those autocomplete kind of things. So, all right, well, hang on, let me back up a second. All right, maybe if I do it a little bit differently, I take away the level 1. Is that going to work? Yes, there it is in the drop down. Pick that. Brilliant. No, don't give me the extra stuff. Again, this is not me. This is the AI doing all this. It says we can't deliver now. It's 11 p.m., but you can still place an order for later. That's good. That's what I want to do. It's Wednesday when I want the pizza. There's pizza. I click on pizza. Again, not me, the AI. Clicks on pizza. It selects a large pizza. Lovely. Adds it to the cart. It's going to have a look at it. That's a Supreme. That's UI is terrible. Bloody hell. All right, now I can't figure it out at all. All right, let's get rid of that. Remove that. Close that back down. Where was the pepperoni? Oh, I've got to scroll down. There it is. Okay, great. Nope, I went too far down. That's Vietnamese chili chicken. Hang on. There we go. Pepperoni, large, lovely. Thank you very much. I don't want extras. Thank you very much. Brilliant. Let's check out. All right, now, good. Here we go. Oh no, what's that error? Oh, delivery has to be at least $25. So it asked me in natural language, hey, delivery has to be $25. So I said, great, get a Coke. So it just added a Coke on, and it looks at the delivery scheduler, picks Wednesday, picks 8 p.m., goes down to the details and goes purchase. Now, at this point, it hands over to me. It says, I don't have your payment details. Can you please take control, enter your payment details? It doesn't record when it's entering payment details, which is very nice to know. And then go, and then here's the pizza. So enjoy, everyone. And that was my first try. I just went, all right, let's see if this works. I gave it a little bit of custom instructions, so it would know some basic details like my name and my address and all that kind of stuff. And then that was it. So how does that work? Well, as the input, you give it the prompt. I want pizza. I have custom instructions. So if you've used ChatGPT, you know that there are custom instructions in ChatGPT that allow you to give it basic information about you that it knows every time. So you don't have to say, my name's Ulysses, I live at this address, I would like a pizza please, my preferences, whatever, right? I can kind of say, here's the basic information. And I tried, by the way, giving it also login information for my Crust account, etc., which worked as well, which is kind of cool. You can also give it website preferences. So you can say, all right, for pizza, I prefer using Crust. And here's my login and password for Crust Pizza. And then as an output, what it does is it figures out what do they want, makes a plan for how it's going to try and do it, opens up the browser, and it looks at the screenshot. It's looking at the screen, it's doing inference, so figuring stuff out on the screen, it's taking a coordinate of where it wants to click, and then it's clicking on that place. So it clicks buttons, it enters text, etc. And then when it gets stuck, it can either ask the human in natural language, or it can say, can you please actually just fully take control of the browser now and just you do it, and then hand it back over to me again when you're done. So, a good tip for this is, if you're anything like me, you're a little afraid of what this is going to do, right? Like it's acting as you online. So financially, you can give it access to a bank account which only has like $50 or $100 in it or something. So even if it goes off the rails, it's not going to break the bank, and that way you can actually let it have kind of full action, actually do something, be useful, because by default, if you open up an incognito browser and it doesn't have any of your cookies and it doesn't have any of your standard kind of logins and stuff. It's a pain in the ass. Well, that's basically the situation that this has. So you kind of have to give it all the stuff that would normally be in your cookies and in your, password managers and all that kind of stuff if you want it to be useful. So it's slow and it's fumbly, right? You saw it made 2 different mistakes. It ordered the wrong pizza twice before it figured it out, but it did get there in the end. But APIs are a better solution. If you know you're going to need to order pizza every Wednesday, just connect up to the Crust API and do it more efficiently and more directly. But the internet and the world was designed for humans, right? Most things that you can do online can be done by a human. They can't necessarily be done by a software system. So what this means is you can build into all the APIs you can think that you might need, and then you tell the agent, use the APIs when you have them, and when you don't have them, switch to operator. I'm going to pause there because that's a big deal. Do you understand that? So we're no longer limited to say, all right, I have built a software system and it can do X, Y, and Z. You now have a software system that can do X, Y, and Z quickly, and then everything else slowly, right? And then as you work out, okay, we keep on defaulting to operator for this same use case over and over again, then you build in the APIs for those systems. So that's huge. That is absolutely massive. However, it is slow. The joke that someone made was that this is great. Now I can do in half an hour what used to take me 5 minutes, right? But you're not doing it, right? Your hands off, you're dancing, right? It's kind of amazing. So this is gold for front-end testing. So sorry, Selenium. I don't know if you guys know the testing framework Selenium for front-end stuff. You're out, operators in. So competitors for this are Anthropic's computer use, which got there first. And when Anthropic did it, it was a flaming car wreck, basically. It did sometimes order you pizza, but sometimes it would go off and just look at views of the Sydney Harbour Bridge for no reason. Like it was very hit and miss. So the fact that this is fumbly but eventually competent is kind of a big deal. And then there's an open source one on GitHub called Browser Use as well. So you do have options, but Operator is amazing. So this is OpenAI's Operator using another agent system called Replit. And this is kind of fun because this is 2 agents just talking back and forth, right? This is maybe the future of the world is we're going to end up with this situation where we're not involved at all, right? It's just agents calling agents calling agents. All right, now here's the terrifying one for all the developers in the room. Coding agents. We talked before about how reinforcement learning and the clear reward function for that makes coding a very easy target for agents. There are 3 that are talked about. So Devon is purely a coding agent. It's getting better, let's say. It's not amazing yet. Cursor and GitHub Copilot are actually not specifically coding agents. They are coding copilots. They work with you to develop code. And there's something called vibe coding now, which is where you just sit there and kind of chat back and forth with your integrated development environment, and code just sort of happens around you. And we've got a guy called Gert who did that on the weekend, and he came in completely high about it. He was just like, it was amazing. I had so much fun. And he's a solution architect. He's been doing this his whole life, right? So this does allow noobs like me to write code, which is nice, but it also can allow solution architects to write amazing code and recognize when it's good code and bad code. So I'm going to put the volume up on this one a bit because I want you to hear what he's doing.
The GitHub CLI is used millions of times every day and has a backlog of many issues despite hundreds of contributors. Let's take a look at one of the issues. We have a bug report here which highlights a missing validation in the GH repo rename command. This is a kind of improvement that might be on the backlog for a while before being worked upon. What if you could hand this off to your AI assistant so that you and your team can stay focused on the big picture? We're working on a new Copilot agent which will make this a reality. We can assign the issue to Copilot, which picks up the issue right away and gets to work. There are about 200,000 lines of Golang code across 700 files in the repo, so Copilot has to do some work in the background to figure out what to do. After a few seconds, Copilot spins up a draft PR and links it to the issue we created, which we can see in the issue timeline. In the PR description, Copilot has shared its implementation plan, so we know how it is approaching solving the issue. As it continues working on the task, Copilot keeps updating the PR description and pushes incremental commits so we can follow along to its progress on the changes. A few minutes later, Copilot updates the PR description with a summary of the changes it has made once it has completed working on the PR. It has also pushed commits with the final changes, requested a review, and marked the PR as ready for review. Let's take a look at the changes it has made, which are across multiple files. We can see that it has implemented a fix for the bug while also following all of the conventions of our repo, like code style. Copilot has also updated the tests and run them to make sure they're passing before pushing the code. While reviewing the changes in the implementation, I noticed that showing an error message to the user would be helpful if validation fails. I can ask Copilot to improve that. I will select parts of the code and add a comment that specifies to add an error message. I will submit my PR review requesting for changes so Copilot can make the necessary modifications. Copilot reacts to my comment to let me know that it has seen it and is working on it. Soon, Copilot replies to me with a detailed comment on the changes it has made and also pushes updates to the PR addressing the comment. Let's take a look at the changes it has made in the PR.
You get the idea. So that's kind of amazing, right? That's doing the work of a junior developer. You're giving, at the moment, your easy work items to that. As it gets better, you can give it harder ones. It's a good example also of how an agent can work in conjunction with a human in the loop who's got more context, more understanding, who can notice when there's problems or requests, improvements as you go. And it feels like that looks and feels a lot like how I feel when I'm working with my developers. So this is a big deal. SWE is Software Engineer Agent. So the work item is the prompt. So in your backlog, you have a to-do list, and each one has the details of what you want done. So that just acts as a prompt. And then the code base is the context that it's working within. So it shares its plan. It then implements the plan. I like that it shares its plan, by the way, because it feels like you can go, no, 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 at some point if you want to. Then it implements it and then updates the tests and the documentation. Devs in the room. Yes, please. This is a step that's commonly skipped. And then it submits a pull request for review. Yeah, that's mind-bending. We have our own AI system called Yak Shaver that puts easily turns human videos and audio into work items. So that I'm assuming is going to end up feeding this for a full end-to-end Java type experience. So when to use agents versus when to use the AI-enabled workflows. So first up, a workflow, just to recap. It's structured and it's predictable. You know pretty well what's going to happen, which path it's going to take. By the way, there is still some temperature or randomness to everything that it does. That's how generative AI works. So you can't be 100% sure exactly how it's going to go, but it's pretty good. And this lends it really nicely to things that require strict compliance or governance, where going even a little bit out of what you expect is unacceptable. Now, because you're running corporations of lots of people, putting lots of thought into making sure you've worked out the exact best workflow for these tasks to go down, it's computationally efficient. It's cheap to run compared to an agent at the moment. So it does depend on the humans, right? Your humans your developers or your product leads have to figure out ahead of time everything that the user might want to do. And if the user tries to do something that you haven't assumed that they're going to want to do, they just can't do it. It can't operate outside the box. It doesn't even if it has access to the tools that it should be able to do the thing that you want it to do, if the developers haven't made the exact workflow for it, it can't do it. So you use this for well-defined or narrow tasks. If you've heard of ANI, artificial narrow intelligence, this is a good example where this is a narrow task where you know all the boundaries, you know everything they're going to want, And for those use cases, this is still really good. Now, agents, they're adaptable. If you've got unknown unknowns, like the cat running in front of my legs as I'm trying to get out the door, right? It can handle that. It dynamically adjusts its approach. So I'll step around the cat, I'll pick up the cat and feed it, whatever. I replan. It gets better over time. So again, you can do a reinforcement learning run on it. You can do continuous learning. This is a really important point, the model that you use. So the model is the LLM. Let's say you built an AI workflow in the era of ChatGPT 3.5, right? And all of your decision trees were simple enough that that level of intelligence could handle it. Then when GPT-4, GPT-5, GPT-6 comes out, your system doesn't do anything it didn't do before. It's still the same level of intelligence. Your intelligence of your system is really defined by your workflow as opposed to the intelligence of the model. It's like, I like to think of it as an AI workflow is you're strapping yourself to a carriage of the train that's sitting on the side, and it's just going to stay there. But an agent, you're strapping yourself to the moving train, right? When GPT-4 comes out, GPT-5 comes out, GPT-6 comes out, you don't do any extra work or very little extra work, and your system is just much more capable now. So if you are betting on the exponentials of these systems continuing to get substantially smarter over time, then an agent makes sense, maybe even for a more simple use case. Ask Callum, he'll tell you agent every time, pretty much. So it is less predictable, especially at the moment, and it's more creative. That might be a good thing or a bad thing, depending on how you look at it. As I said, it's not looking at the most optimal solution every time. It's figuring out the whole solution space every time. So it's maybe more expensive, more computationally expensive to run for each case. For now, right? The Lee Sedol thing we talked about earlier with the Go World Champion, maybe eventually with enough reinforcement learning and a smart enough model, it can figure out a better solution to the problems than we can. So you use these for open-end or complex tasks, right? Researching something difficult, driving a car. There are many the solutions, problem spaces that you can think of where this might be a good use case. This is my recommendation on when to use what today, right? I'm assuming I will speak differently in a year. So use an agent when you want a problem solver that you can delegate tasks to rather than a fixed procedure. Okay, that's your takeaway. So, we talked about a few limitations of agents, but you still want to be able to use them. And there's a lot of people who are terrified of the concept of agents. They're like, oh, it's just an agent of chaos, right? It'll just go off and do its own thing. I have no control. But I think you should think about it like hiring a new employee, right? A new employee is an unknown. You don't know their backstory. You don't know what they're going to do. You don't know how they think through problems. So if you hire a new accountant and you give him the company credit card, right? You don't just do that and go, good luck, buddy, right? You give him a certain amount of boundaries and what he can do, what he can't do, maybe some oversight, all that kind of stuff. And you should think about agents the exact same way you think about hiring a new employee. So you might have another human in the loop. So like we saw with the pull requests, it's reviewing the work that it's doing, it's giving approvals, maybe you have an approval gate before it can actually do the action it wants to do. And just like in the GitHub Copilot SWE agent, it might say, okay, I see what you're trying to do there, but actually do this slightly differently halfway through the task. So before it's finished, you might give it some additional context and say, no, don't go that way, go this way. You can inject more context. So as you go along, you realize halfway through the task that it's gone off the rails, so you can just readjust it, tack it back on course. You should have the ability to undo and roll back, right? We found this, we're building I said before, Yak Shaver, and we realized pretty quick that if we didn't have an easy way to fix mistakes, we were going to piss off a lot of people. So we wanted to make sure that even if it works 90% of the time, it fails 10% of the time, you want an easy and graceful way to get out of the problems, right? An easy way to roll back, an easy way to delete what you've done, undo it. You want some strategies like, okay, the agent didn't work, so what do I do? Maybe I pass over to a human, or maybe I have a default thing that happens in the case that I'm not really sure what to do. Self-correction is interesting. So this is where it might get to the point that it's just about to do the thing, and then it does a little check, and it sees its own problems, and it goes, wait, hang on, no, I don't want to do that because of these reasons, so I'll back up and I'll go a different way. So having it fix its own problems all the way through is a good one. That's used a lot at the moment. And guardrails. There's something called constitutional AI, which is the concept of giving it values, explicitly giving it values. That's at the model level, but you can use the same concept with your agent systems, which is basically saying, here's the goal, but don't do this stuff, don't do that stuff, don't do this stuff. If you see this kind of situation, then lean towards this. Like, give it some guidance and give it some boundaries of what it can and what it can't do. And this solves a lot of problems with instrumental convergence, which is where sub-goals are damaging, even though they're useful for the end goal. Rate limits, by the way, sorry. Rate limits are also interesting. So that's where you say, okay, don't just spin your wheels forever. Like, give it a timeout. And then logging. Give it some ability for the developers to go in and go, what did it try and do here? Like, log and trace what you're doing so you can go back and go, oh, okay, I see what it tried to do. And then you can put in new guardrails as you go. So this is really useful. I'll put this in one of our SSW rules, so this will be documented, and I'll try and fill out a little bit more, because this is good stuff here. So the last system I want to talk about is a hybrid, right? You don't have to use an agent or an AI workflow. You can use a combination of the two. So here's a situation from before. This was purely the AI workflow we had. So the customer sends a message, AI analyzes, looks at the knowledge base, figures out if it can already answer the question, brilliant. It can't answer the question, so it escalates to a human. No, wait, we don't need to. We escalate to an AI agent now, right? So for the use cases that it can handle, it handles it. For the use cases it can't, then it goes to the agent. That's nice. That gives you the predictability for the cases where your everyday 80% kind of cases, but the flexibility to still handle the oddball, weird questions that come in from Mike down the road. Sorry, Mike. So predictable outputs for anticipated use cases, but flexible for unanticipated ones. So how do you build them? First thing is, an agent can only do what it has access to, right? Like, if I'm a robot, I can only push things around if I have arms. Yeah, so mostly. So I need to understand, if I'm an agent, I need to understand what I have access to and why I might choose to use that tool versus another tool. So you do that with a textual description, literally just saying, hey, this is your arm, it's used to pick stuff up, right? Yeah, like explaining in natural language what the tool is for. A function, so what is it that it does? Actually, how do I call this thing? So for instance, searching the web search. Some arguments, like the query, like what do you want me to search for? And then outputs. Outputs is interesting because this gives the AI the context of, right, if I do that thing, what am I going to get back? So there's a few frameworks that you can use for AI-enabled workflows. There's pro code and there's low code. So pro code is for developers, low code is for us. Me. So pro code, you've got LangChain. That was the biggest one and the leader for a long time. Semantic kernel is now a strong competitor to that. That's from Microsoft and it's open source. As SSW, we use semantic kernel a lot. And the whole Azure AI Foundry has a lot of ways to use pretty much all the large language model stuff directly via APIs. Low code. This is a really interesting space. You can do a lot cheaply now. For prototyping especially, this stuff's gold. N8N is a relatively new player, but it's taken the world by storm. It's huge, and it's open source. It's a competitor to Make.com, if you've ever heard of Make.com. These are kind of workflowing systems. Prompt Flow from Microsoft, Copilot Agents from Microsoft, and Agentforce from Salesforce. Can anyone see anything strange on this page? This is AI-enabled workflow frameworks, and I've got Copilot Agents and Agentforce on the list. This is Microsoft and Salesforce jumping on the agent bandwagon and trying to ride the hype train. I think they've done this because even though neither of these low-code systems actually can produce agents yet, I think that they assume that they will one day, and they just want to, get in everyone's face now. So just know that if you're actually trying to build an agent, you can't use Copilot Agents and you can't use Agentforce yet. So to actually build an agent, how do you do it? And by the way, this was hard to find out. I've been to AI conferences, I've talked to AI developers, and I've done deep research. This is what I found. So Microsoft AutoGen is our chosen framework. It's what we tend to build most of our stuff on. And by the way, it's merging with semantic kernel, so you'll be able to build workflows and agents with it. Whether or not you're a Microsoft dev, it's a strong choice. LangChain can be used to build agents as well as workflows. Crew AI, Llama Index, and small agents is a cute one. It's an easy to use one from Hugging Face. If you're just getting started, it's a nice way to start. And Swarm. Swarm's interesting. Swarm is open source. It's made by OpenAI, and it's not fully supported by OpenAI. I don't know whether they're going to or not. When they came out with this, we were all very excited. But the concept of it is it's designed for multi-agent frameworks. So if you have one agent that spins up another agent that spins up another agent, it's experimental at this stage. If you're building a important production system, I wouldn't use it yet. But if you're just trying to see what's doable on the very fringes, try Swarm. And all of these are open source, which I think is fascinating because there's a real open source movement going on at the moment. I don't know if everyone's been paying attention to AI news, but even OpenAI, which has been heavily criticized for being called OpenAI and having nothing open source, is thinking about moving some of their models to open source. Don't hold me to that. That's conjecture at the moment. That's Sam Altman. Okay, so what's coming next? This from here on out, up to this point, everything is facts. From here on out, here's my guesses, okay? So here's what I think is coming next. Oh, sorry, hang on. Oh, hang on. Sorry, hang on. Well, I mean, at least that one's an agent. Hang on, wait a sec. Okay, all right, sorry. Now, OpenAI has thought this through themselves, and they've given a 5-level framework. So we had chatbots, right? November 2022, ChatGPT, we have chatbots. Chatbots are great. Everyone should have a little chat icon on the bottom right-hand side of their website to explain in plain language what the hell they do, especially if they have complicated businesses like SSW. These are useful, but they can't do anything, right? They can just talk. Then level 2, reasoners. This was the unlock, right? This is where you start to trust the judgment of an AI system because it starts to make the same kind of calls you would, right? You give it a certain amount of context and it goes, oh yeah, well the best path is this one. Or you give it a difficult coding problem or a math problem and it can answer the question. It can produce content that's actually useful. It can start to hook up to APIs and tools. Now you trust its judgment, you let it act. Agents, we've just talked about agents. That's where we're at now. After now, right, moving into the future, the next thing will be new science, AI capable of producing brand new physics, new mathematical concepts, right? We're touching into this space a little bit. If anyone's paying attention to what DeepMind is doing, there's AlphaFold, there's a whole bunch of GNOME, there's a material science, drug discovery, there's a lot of stuff happening around just doing brute forcing the permutations of everything that's possible. But when we're able to really take off is when the job of an AI researcher can be automated, because that has a recursive effect and a runaway intelligence gain until we get level 5, which is the full intelligence of one AI system having the intelligence of an entire organization. So an AI that you can talk to that is as capable as Google or Microsoft or NVIDIA. Right? That's also known as ASI, artificial superintelligence. And interestingly, this sounds like sci-fi, but this is like now that we're at agents, and AGI is somewhere around level 3, level 4, artificial general intelligence, human level intelligence. These big companies like Safe Superintelligence with Ilya Sutskever, who was the ex-chief scientist of OpenAI, and even OpenAI now have shifted the goalposts. They're no longer aiming for AGI, they're aiming for ASI. They're aiming for superintelligence. So this is something that's being actively worked on now. This isn't science fiction. This is where we are now, right? We're just at the birth of agents. As I showed you, the agents that I showed you all came out in the last month, right? So this is brand new, but it's pretty exciting. So what I think is coming is that large language models will keep getting smarter, right? There's something called the scaling laws, which mean that the more data, the more compute, the more smarter algorithms, that everything you dump into the training run makes the model smarter. That was true for a couple of years, and it kept getting smarter and smarter and smarter, and then it started to peter off. And then a new paradigm came along called inference time compute, which means instead of all the brains going into the training of the model, some more brains goes into the chain of thought when you actually ask it a question. So if I say, what's 5 times 5? It's going to go, ooh, let me think about that, and it's going to think and think and think and think and think, and maybe not 5 times 5, but something hard, and then give you the answer when it's confident it's got it. Right? And there's a lot of headroom in that new scaling law. So we're still going to get a lot smarter. It's also ridiculously cheap. We're 2 years into this. What per unit of intelligence 2 years ago from now to now is 100 times cheaper. So it's a 10 times improvement in intelligence per dollar for 2 years running. And that is probably going to continue again. This is a 10 times order of magnitude every year. To give you an idea, Moore's law is 2 times every 18 months. This is 10 times every 12 months, right? So this is taking off like crazy. It's going to get smarter, it's going to get cheaper. Also, there's something called small language models. There's a process called distillation, which allows a large, very intelligent model to teach a smaller model. They have a teacher and a student. It gives it something called soft targets, and it's like a professor who's literally read every single textbook on physics, who then gets a smart student in and just teaches them what they actually need to know to understand physics. So it's a much smaller model. It doesn't have access to every single line of every textbook. It just understands physics. Okay? So we're going to get these small language models, which will be as smart as the large language models are now, which opens up the ability for them to run on your phone, on your laptop. Copilot Plus PCs will have their own little chip, a TPU, MPU, which will run a small language model here, right? Rather than going back up at the cloud, churning through huge amounts of compute, you're going to have good intelligence in your phone, offline. There's a lot of fear at the moment of people thinking, okay, everything that I ask a large language model, it's going up to the cloud. I have to trust OpenAI that they're not going to do anything with my data. This can run air-gapped. So a much smarter Siri, which I want. So agents are going to become ubiquitous, and software as a service will become less needed. That's a big deal. And it sounds like a ridiculous claim until you realize that this is the claim that's being made by Satya Nadella, who's the head of Microsoft, and Mark Benioff, who's the head of Salesforce. These are the two largest SaaS companies in the world. Both their heads are saying SaaS is dead, agents going to take over. So if they think this, it's probably worth taking note of. So that's everything. We went through what AI agents are. We talked about how to compare those against AI-enabled workflows. We looked at some real-world examples. We looked at when you use which, how to build them, and what's coming next. So if you want more, we have 73 at the moment rules on our ssw.com.au/rules on AI. We're going to have a lot more. We're keeping all our learnings as we learn things. We're putting them here on the SSW rules. So, and I've put this presentation up on GitHub. You can go through and zoom in on my full deep research thing if you want to look at all those links. So if you have feedback for today, I would love to hear it. So you can use this QR code to fill out the feedback form. That would be really useful for me. So guys, thank you very much.
Yes.
All right, thank you, Yoli. That was a great presentation. Awesome. I'd love to take some questions if anyone has any.
You didn't mention that. I was just wondering, what's your view of it?
Yeah. Okay. So Gemini 2.0 and Flash is their mini model. It's their smaller model. Very, very strong models. That's Google's models. All of the images that I used with my little cyborgs doing different things, that was all by Imagen 3, which is part of the Gemini family, one of the Google tools. The reason that I tend to stay using OpenAI tools instead of switching over to Gemini or Anthropic's Claude or Grok 3, which came out yesterday, is purely I have a lot of stuff in that ecosystem already. I've built custom GPTs in that system. And if you look at just a histogram over time, over which company is in the lead, OpenAI is usually in the lead, right? It's not necessarily in the lead at any given moment, but if you just had to pick a random day, it's probably OpenAI in the lead at that time. So yeah, that's why I tend to stick with OpenAI. But a lot of people get a lot of use out of Claude 3.5 Sonnet New and out of Gemini 2. And Grok 3 apparently in all the benchmarks is doing extremely well as well. And even DeepSeek if you're wanting to roll the dice.
Can we get the mic back to Graham? Graham, you've been in the industry a fair while. You know a bit. What were your thoughts on this talk?
I haven't been in the industry very long at all, actually.
Author from Harvard.
Yes, and thanks to my co-authors. So my background is in business strategy. 2 years ago, I got interested in AI because I thought, how is this going to impact the practice of strategic planning? And then over a period of time, I linked up with some amazing people, which you've probably seen in my list of co-authors there, and we've together put that material together. But I'm not an expert in AI. I'm really interested in that link between AI and strategic planning.
So try the deep research tools. There's a couple of free ones. The Perplexity one is free. The Grok one's free, and the really good one, which is the OpenAI one, is coming to the $20 a month tier in the next few weeks.
Awesome. James, you've been doing business since before I was born. What were your thoughts?
Excellent, a brilliant talk. I think it's always difficult when you have to start out with concepts and terminology, so particularly acronyms and things like that, which is it makes it a tougher start. But it was an excellent talk. I think one thing I have a particular interest in. So being in the business of holding and managing other people's data now for the last sort of decade. We started the wrong way around when we looked at AI originally. We looked at it as a problem for how do we make our business better, whereas what we've now realised is we need to be in the game of doing adjunct tools that utilise the foundation we've already built. And sometimes, I mean, the biggest problem we've always had with AI is what's the question you're trying to ask? If you don't have a question, there's no point turning anything loose on it. A goal or a question. So I think the agents have moved it on to what's your goal. But finding that and finding what the question is often the most difficult challenge.
Yeah, absolutely. So there's a lot of people who are young and new graduates and looking at what skills do I need to push and get good at for my career. And it used to be that you needed to kind of go deep in one space, become a specialist, and then you're the guy for that one thing. Now the AI generalist, right, is the champion of this because they have the most context to then be the most creative about thinking, what if we pull on this strand? What if we try this or try that? So you want to know a lot about a little now, and then you use AI to then go deep into whichever space you want to go. So creativity, funnily enough, people when generative AI first came out, it was doing all the writing and the art, right? And everyone was joking, I don't want AI to write poems and do art. I want to do that. I wanted to do the boring stuff, right? But actually now we're back again to creativity being king because, as you said, if you don't know what to ask it, it's just sitting there. It's not doing anything. So you have to know what ways you want to pull, what you think might generate value.
Articulating a goal or a problem, which is what we struggled with.
Yeah, and actually, so prompt engineering was a big deal early on. And then the systems got better at inferring what you probably want from a poorly worded prompt. But now with deep research, again, we're back to good prompt engineering because you've got to give it really good context and give it the why of what you're trying to achieve as well, because it could go so far before you realize where it's gone that prompt engineering has become important again.
About 12 to 18 months ago, Yuli and I sat down about how do we get every single person in the company using AI. And we started with prompt engineering.
Yeah.
We made a whole lot of cheat sheets. You might have gone into some of our toilets here, wherever they had to answer these questions every week. They had to get good at prompt engineering. Wherever they went, if you went into the toilets, you saw it. Every answer that we were giving on emails had the prompt, etc. So we got everybody up to speed, and then we got it into every one of their jobs. And then we added into the induction. So when people started at SSW, their first jobs were to do a whole lot of things with prompts.
Yeah.
And, we had jobs like, learn about Scrum, because Scrum's important to us. So once you've read the 18-page Scrum guide, then we want you to answer some questions. Now, we would then get a Scrum Master to educate them on what they'd answered wrong. So then we changed it. So everyone that you got wrong, put what was asked and what your answer was, and get it to explain what's wrong. And if you now don't understand it, ask the Scrum Master. So we put all these gates in place so everyone got used to it. Just like you wouldn't say, hey, what's the command for that? You'd say, I've been Googling, I can't find it. What's the command for that? Right. So we kind of pushed that. And once we got, we could categorically say we got every single person good at prompt engineering and then using it in their daily job.
Yeah. We've also changed how we hire. So our employment tests, at the beginning when this all first came out, we went, oh no, what are we going to do? ChatGPT can basically do all our employment tests. So instead of kind of AI proofing our tests, we leant into it and we said, right, we want you to use AI tools. We want you to show us your prompts. We want to see how you use it and how intelligently you use it. And then, we basically just raised the bar of quality. We just said, right, everyone should be able to get here now because you have AI. Show us the good quality and show us how you got there.
And also, don't give it back stuff that we can read and it sounds like it's from AI.
Yeah.
No, that's great. Thank you.
All right.
There's actually an app for that.
Yeah.
Turn it in.
Yeah.
I see all the university students.
Or GPT-0. Yeah, another one.
We do have a question from online, which was, what if we give agents a tool to write workflows to address common tasks?
Yeah, sure, 100%. So the concept of AI agents calling workflows and AI workflows calling agents is definitely something that can be done. But also, you can get an agent to write a workflow for a common task, and that will mean that it takes that same path every time. But for now, that still may not be the optimal path, because an agent, like you saw with it ordering my pizza, it got it wrong 3 times, or twice before it figured out what to do. So for now, I would still have the humans writing most of the important workflows, and pass over to the agent when you're okay for it to fumble around for a bit. That's with the current level of intelligence. Again, that's going up. Levi?
Well done, Yuli. Even if I do have to listen to your voice every day, it was really nice talk. So a company like SSW, so if you don't know what we do, we build custom software. Where could you see agents being intertwined in what we do, like what we build? Like you and I are quite, well versed in building custom GPTs and things like that, but where do you see agents now if we were to tomorrow go and play with a few, build a few and implement them?
Yeah, look, I think it's going to chip away at what SaaS is doing currently. So for instance, for us, we have a SaaS system, right? And we have our bookings engine, which is famously painful to use. That was something that Callum built as a simple agent, over a weekend as a prototype.
That's not painful.
Well, sure. Yeah, but I mean,
It's painful at the minute.
yeah. No, I know. That's what I mean. Yeah. But I mean, it was disrupted by Callum building a simple prototype, which is already he hasn't even taken it past prototype form, and we still use that more than we use the old system now. So, yeah, just finding the areas where you have most pain and handing that over to an agent, giving the agent the tools that you need to interact with the systems that you want. That's kind of the first step. Also, actually, that's not the first step. The first step is you already have workflows, right? You already have human workflows and tech workflows. Just chuck large language models in at a bunch of the key decision points for that. Then, once you exhaust the sort of things that you've already figured out the efficient paths for, then let the agent do all the stuff around the edge. So I keep talking about Yakkshaver, but Yakkshaver we built as a full workflow, and then we gave it to the 100 staff at SSW. And 80% of them used it the way that we thought they would, and they got the results that they are getting themselves. And the other 20% talked to it completely differently and asked for things that we hadn't even thought that they'd want. So the idea of Yakkshaver is you say, I found a bug on the SSW website, I click here and it's supposed to go there, but it goes here instead, fix it, right? But they would say something like, oh, hey, so I'm here with Adam and we've noticed this thing, and it doesn't look right, but they don't know that it's using voice interpolation, not necessarily the data from the screen to work out what to do. So, or they say, oh yeah, send an email to Bob. Oh, and actually, while I think about it, can you also just email so-and-so, and actually also make a PBI.
Sounds like Adam's emails.
yeah, exactly, yeah. But they tried to do multiple things with one video, and we hadn't anticipated that. We haven't enabled that. It's not possible with our workflow, right? But this is just a few examples of the fact that because we didn't go agentic, it can only do what we thought they might want to try and do. Yeah. Good question.
I do have one real quick. When we're looking at all these different models that are focusing on different things, but we're all getting towards that kind of agent and eventually that, I think you said AI superintelligence.
Yeah, ASI.
What will be the kind of USPs between each different AI manufacturer, if that's the right word for it?
God, okay. Well,
How will they differentiate each other?
Such a huge question. Yeah, okay. So this is what's known as the commoditization of intelligence, right? So because there are many players, there's at least 5 really good players in this space. It's not like, domainandrealestate.com where there's just 2 that fight against each other. There's 5 or so. And now new ones from China as well coming in out of left field. There's a company in France called Mistral who's pretty good. Like there's a whole bunch, right? And what they're doing is they're forcing the price down for each other. Like DeepSeek R1 is a great example. Came out of China, came out of nowhere. They did their training model with $5 million. That is nothing for a training run. I think Google's latest one was 200 million, wasn't it? Yeah. So that's insane. The biggest, so price is one thing, but I think everyone's just dropping on that.
I'm going to mention how they did it using distilling.
So there's some controversy. So there is a pretty strong possibility that the way that DeepSeek was able to do it so cheaply is because they distilled, which I talked about before, their model from OpenAI's model. So they used the public OpenAI model as the teacher, and they used their model as the student, and they were able to get a lot of intelligence using just reinforcement learning and the distillation process.
And we're pretty sure from the results and the fact that OpenAI are suing them because they're saying, oh, you can't go and use our good creative work.
So the joke is that DeepSeek is automating Sam Altman's job, which is funny because Sam Altman's always given flack for stealing other people's work and automating their jobs. The cost, the level of intelligence and the cost, that's the 2 biggest ones. The other one is the context window. So Gemini, as you mentioned earlier, has the biggest context window. The biggest one it has is 2 million tokens. A token is approximately a word. So a 2 million token context window is huge. It unlocks things like importing your entire code base into the application and then asking it to fix something where it knows all about all the other things that might break. It allows you to have full memory of your previous conversations with someone. Like if you're a home assistant or something, you can remember everything you've ever said to that person and use that context for the next part. So that's another unique selling point. And then the last one is its access to tools. So at the moment, OpenAI has custom GPTs. Claude has Claude projects, that's Anthropic. Does Grok have one? I'm not sure if Grok has one. But the ability to very easily produce mini agents that have access to APIs and tools, that's a huge deal. That's the moat at the moment that's keeping us mostly embedded in OpenAI. But if one of the others got much smarter, we probably would switch. Yeah. I like that question.
Can I ask Titus a question? Titus, you're in the video game, running code, but you're always conversing with Yuli. How's your feeling on AI and where it touches your job and your feet?
I was just thinking while Yuli was giving that presentation, actually, that I mean, it's my belief that AI video will definitely completely transform how we do things, and I think the film industry has needed for a long time to do this because it's not a very profitable industry at all. It's literally exists because it's fun and it's entertaining.
Are you saying like when you need a cinematography, I think scenes, drone shots, and different things, or are you saying the entire job?
I mean, long term, it's going to become like Black Mirror with your TV creating films for you that is very specifically, custom tuned to your emotional makeup and what your values are and everything. And as Ashton Kutcher said, why am I watching your movie when I can watch my movie? But just now I'm thinking, well, how is that going to work when it's so energy intensive to create AI video? How is a TV?
Yeah, the costs have to come down a lot to make that.
Yeah.
Economically,
and it also, it's got to get a lot faster because it would just take weeks to create a feature film. Yeah, but I mean, it's that's a really long-term future.
And how long away are we from just getting a major movie that is pretty much...
So there's already some short
AI.
films.
Yeah.
There's already short films out there. There's the Bubblehead one. There's a few others.
Yeah.
Completely turned up red by
June. Oh, June or Doom? Doom. Oh, the game. Yeah.
No, that's right.
There's AI-generated games now as well. Yeah, where every frame is generative. But no, I think we're a little way away. Purely for quality reasons, I think at this point, it's substantially cheaper. Titus was just saying it's expensive, but it's only expensive when you think about like being able to generate any movie for anyone at any time. That's a lot more movies that we're making right now. It's substantially cheaper than the way we currently make movies by orders of magnitude. But there's a quality issue at the moment where there's still a little bit of the uncanny valley, where you suddenly you realize something was slightly off there, a slight twitch of the head, something doesn't look quite right. A lot of AI-generated video stuff is still weirdly, the temporal issues are a bit strange. It moves slowly and then fast, things like that. It works. The use case where it's already being used right now is animation. So where you're not, you're tuned to the real world. If I see Adam and his face glitches, I'm going to freak out, right? But if I see an animated version of Adam and his nose moves to the other side of his head, I'm not really even going to care because it's animated. I expect that, right? So for animation and for gaming, it's a huge deal.
Yeah. So you would already see a whole bunch of SWTV videos when the speaker says that should work like this, and when they meant to say that should not work like this, but the interview hasn't picked that up. Our videographers just picked that up. They even changed one of my outros. I go, hang on.
That's not what I said.
Yeah, I didn't like it actually. I'm shocked. But,
we deep faked it.
Yeah.
Yeah, deep faking is solved, by the way.
Yeah, I just had one quick question. Is Grok open source?
Grok, no, not Grok 3. Grok 1 is.
Yeah. DeepSeek.
Okay.
DeepSeek is, yes, DeepSeek is, and it's open weights as well. So there's open source, which is the code, and open weights, which is the weights and biases. So DeepSeek is fully open source, including the paper on how they did it. So it's very transparent.
But I get why you're confused, because he's
suing OpenAI.
Yeah.
For the same reason.
This is really hypocritical.
Yes. Anyway, if we just send it on to Rick. Rick, you've done a lot of development, mainstream, building SQL tables, building your own APIs and front ends, and then you've got thrown on an AI project. What was the biggest, head spin of getting your head around this project compared to normal, traditional development?
I think the first challenge will be prompt engineering. So, as English is not my first language, so when I first write the prompts, it didn't work at all, or it doesn't work as expected. And then I get my tip is I get the AI to improve my prompt. So that has got a lot better. And now I get used to write prompts myself.
Right.
Yeah.
And how did you feel working on Yak Shaver? Was that a fun project to work on, or like how different is it from a normal mainstream?
Do you want me to do this? I can.
No, it's okay. Yeah, I really loved it, and it just opened up a new chapter in my career. So I moved from backend API, and now it's all about AI and creativity as well.
Yeah.
So
for those who don't
great.
know, Rick and Callum between them dragged me kicking and screaming into the agentic era because we had, as I said, built all the workflows for Yak Shaver to work perfectly for every use case that I could think of. I'm like, why? Don't break it. It's brilliant. It's like it does exactly what I want every time. It's wonderful. But then Rick, in 2 days, built an agent prototype, which pretty much did most of the job straight away.
Yes.
And I went, all right, fine. So that was pretty impressive. And yeah.
And the big question, what was your product owner like?
Very open-minded and very responsible.
I'm talking about you.
Handsome?
Yeah, you forgot handsome.
Yes.
All right. Is there any other questions? Kate, we have a question.
We have a question from online from our resident Frenchie.
Hold on. Can we just do...
Oh, of course.
You can do that.
All right.
So,
From France.
from France. Yuli, don't you think beauty/interest lies in the imperfections of what humans do? I mean, you can generate a gazillion perfectly made tunes, movies, or games, and they'd be boring to most humans because we care about imperfections in art.
Yes, absolutely. And that's where the nuance of a good goal comes in. So you don't say, the perfect example of this is Facebook, right? The Facebook algorithm is an AI algorithm that was optimized for a goal to maximize user engagement, right? The output of that has been teen suicide. We had, a massacre in, I can't remember, Geneva or somewhere, where, Myanmar, where this is basically just forced massive amounts of polarization because outrage engages better than love, right? So they optimized for the wrong thing, and then it had horrible runaway effects. So the idea, and this is an ongoing problem, is figuring out the right nuanced goal. What's the objective function that you should set? Don't set a one-dimensional objective function. Set interlacing objective functions, right? We want, world peace. We want everyone happy, but we don't want everyone happy because they have hooks in the corner of their mouths pulling up, right? So we need to give lots and lots of ways and different interlapping objective functions. So, for instance, Jean's example there of, the perfect situation. I don't know if you remember The Matrix, but Agent Smith says to Morpheus in the first film, I don't know what's wrong with you people. We gave you a paradise. The first iteration of The Matrix was a paradise. Everything was perfect. And your horrible monkey brains rejected it. You couldn't handle it. You needed the struggle. So here we are. This is, whatever it is, the late 90s or whatever. This is the peak of your human civilization. This is when you guys like just railing against the machine the most. And so this is where we put you. This seems to be where you're happy. So, that's an example of an AI figuring out what the humans actually want as opposed to what they say they want.
All right, so let's finish it off with Kate.
Hi, Mum.
I just wanted to know one thing. Sorry, I just wanted to know one thing. Do we sell our NVIDIA shares?
No, is the answer. Not yet. So there's a thing called Jevons paradox, which, the reason why everyone suddenly sold their NVIDIA shares and why it dropped 17% in one day is because DeepSeek R1 came out and said, hey, look, we did this with a $5 million budget. You're all buying NVIDIA shares like NVIDIA, hardware like it's going out of style. You don't need that much compute to do this. Look, here's how to do it much cheaper. The thing is, Jevons paradox says basically the fact that it's cheaper opens it up to more use cases. So like Titus said, if it's cheap enough to make a movie, I'm not going to make the same number of movies I make now. I'm going to make a different movie for every single person every night of the week. Right? And the idea is Jevons paradox says that scales up more than the price scales down. So NVIDIA is still a good buy.
So just very quickly, will the DeepSeek model being much cheaper, are they now able to use, have they got hold of what the DeepSeek model is? And
yes, it's open source. So DeepSeek, by the way, is not an AI company. They're a quant company, right? So their original job as a company is to do algorithmic trading. Just on the weekend, let's pump out an OpenAI level reasoning engine. There's a lot of conjecture that they had access to more NVIDIA hardware than they're saying, that they spent more on the training run than they are saying they did. Also, as we said, they distilled the OpenAI model, so they weren't starting from scratch. They had a teacher model that was giving them more intelligence. It has proved that it can be done. There are some very clever people in China who figured out how to work with less. They had embargoes around how many chips they were able to have access to.
They certainly couldn't use the new chips. They used, the basic chips, basically.
Did they?
Well,
mostly.
pretty sure.
Probably, I don't know. We can't tell for sure. But they definitely made some smart choices, but they made it completely open source. And there is a theory, I'm being recorded, there is a theory that they did that to destabilize America at the time when there was a change in
Isn't there a conspiracy theory?
Sure. Who knows?
They're just a few kilometers from our office in China, in Hangzhou. So they're around Alibaba, and as soon as we all heard about DeepSeek, we got excited and called them and said, oh, wow, you heard about this, and they've all been using it for weeks. So they were many steps ahead of us already. They thought nothing of it.
Interestingly, so we have an office in China, and we did a sales video today. We were looking at the sales that have come in and the projects that have come in, and we've actually had as many new opportunities around AI in our China office, which is much smaller than we have in our Australian office for the last month. So there's a huge surge in work and interest in China around AI.
Yeah, and I should also say, our business is pretty much mostly doing cloud, Azure, Dynamics, .NET solutions, front-end stuff, websites, Tina. All of a sudden, AI is our number 2 category.
It's overtaken mobile, it's overtaken data.
Yeah.
It's the calm before the storm for it. I work with that.
Yeah. Yeah, it's coming.
Awesome. So thank you all for coming tonight. Thank you everyone online as well for joining. And this is Yuli. Thank you so much for putting in such there's a lot of work in putting a presentation like that together. So thank you very much, Yuli, and thank you everyone. We'll see you next month. Cheers.
Thanks.